This work studies the importance of tactile sensing for imitation learning. It does so by centering on the dynamic manipulation task of igniting matches, a task for which there is evidence that the availability of touch sensing impacts human performance. To conduct the comparison, we also propose a modular, multimodal imitation learning framework for efficiently learning fast and dexterous manipulation policies through flow matching. First, the policies process the observations inside the observation encoder. The resulting vectors, together with the actions, are then fed into a transformer which outputs velocity vectors for refining the actions. After 5 refinement steps, we obtain the current desired end effector trajectory. To ensure reactivity, the robot controller only considers the first action of the trajectory, before updating the targets based on the next prediction. The experimental setup consists of a Robotic gripper mounted inside the end effector of a Franca Panda. The gripper is equipped with the EVE-TAC event-based optical tactile sensor. Visual observations are provided by a wrist-mounted RealSense camera. We attach the striker paper to a 3D printed holder and use a match cover to protect the tactile sensor. Given the setup, we collected 20 expert demonstrations through kinesthetic teaching. Based on the collected data, we subsequently trained different policies to investigate the importance of touch sensing for the dynamic manipulation task. As shown in the videos, the policies that receive vision and touch as input outperform the vision-only policies. They achieve significantly increased success rates by at least 40%. The next experiment investigated whether a masked training procedure that leverages the tactile observations only during training can improve policy performance. As shown in these videos, leveraging the touch signals only during training through the masked training procedure is effective and increases the policy success rates by a factor of 2. We next evaluated whether the policies can generalize to the novel scenarios of using different matches or a different striker paper. As shown in the videos, we find that the visuotactile policies consistently outperform the vision-only policies, with persisting gains across various demonstration regimes. The next experiment compares the performance of our approach against baselines. The experiments underline the importance of our approach's components and show increased success rates. Lastly, we investigated whether the findings transfer to a whiteboard erasing task. As highlighted in these videos, we again found performance benefits arising from both the integration of tactile sensing into visual motor policies, and our proposed approach. In summary, we conclude that touch is a crucial sensing modality for learning robust and reliable policies on dynamic manipulation tasks from few human demonstrations.